Hi guys! In this video, I'm going to discuss on right triangle trigonometry, the 6 trigonometric ratios. So I have here a right triangle with theta at angle A, and we have here angle C and angle B. Then opposite of angle A is side A, then opposite of angle C is C, and opposite of angle B is the side B. Now, A here is just the opposite of theta. This is the opposite. Then C is the hypotenuse. And B here is just the adjacent side. Now, if we're going to look at the 6 trigonometric ratios, you have sine of theta equals opposite over hypotenuse, or this is equal to A, the opposite side, over C, the hypotenuse. Then cosine of theta is equal to adjacent, which is B, over hypotenuse, which is C, so B over C. And tangent of theta is opposite over adjacent, that is A over B. Then the 3 trigonometric ratios here are just the opposite of 3 here. So these are just reciprocals of the 3. So cosecant of theta is equal to hypotenuse over opposite side, C over A. Secant of theta is equal to hypotenuse over adjacent side, or C over B. And cotangent of theta is equal to adjacent over opposite, B over A. Now these 3 here follow the mnemonic SOHCAHTOA. So these are just the mnemonic that is used so that you will not forget the 6 trigonometric ratios. So sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent equals opposite over adjacent side. Example number 1. Find the value of the 6 trigonometric ratios of the angle theta in the given figure. So this is the figure here. This is the angle theta. So the adjacent side here is 4. The opposite side is 3. And the hypotenuse is 5. Now, if we are going to have the 6 trigonometric ratios, first we are going to have sine. Sine of theta equals opposite over hypotenuse. So opposite side is 3 over hypotenuse is 5. So sine of theta is 3 over 5. Then cosine. Cosine of theta equals adjacent over hypotenuse. So we're going to have here 4 adjacent side. Then hypotenuse is 5. Then tangent of theta is equal to opposite over adjacent side. So opposite here is 3, so we're going to have 3 over adjacent side is 4. Then if we're going to have the reciprocals of the 3 here, so sine, that is cosecant. So cosecant of theta equals the reciprocal of this one, that is 5 over 3. Then cosine of theta, the opposite is secant of theta. So secant of theta is equal to 5 over 4. Is hypotenuse over adjacent side. Then cotangent of theta will be equal to 4 over 3. So these are the 6 trigonometric ratios of the angle theta in this figure here. Example number 2. Find the value of the 6 trigonometric ratios of the angle theta in the figure below. So this is theta here. So hypotenuse here is 13. The opposite side here is 5. And the adjacent side here is unknown. So what we're going to do first is we're going to find the length of the adjacent side. So finding that one using Pythagorean theorem, we're going to have adjacent side squared plus opposite side squared, that will be 5 squared, equals the hypotenuse squared, 13 squared. So adjacent side squared plus 25 squared is 5 squared, 13 squared is 169. Then adjacent side squared is equal to 169, then minus 25. Then adjacent side squared, 169 minus 25, that will be 144. Then extracting the square roots here, adjacent side here will be equal to square root of 144, that is 12. So in here, the adjacent side is equivalent to 12. Now finding the 6 trigonometric ratios, sine of theta will be opposite over hypotenuse, so we're going to have 5 over 13. Then cosine of theta will be adjacent side here is 12 over hypotenuse 13. Then tangent of theta will be equal to opposite, that is 5 over adjacent 12. Then cosecant of theta will be the reciprocal of this one, that will be 13 over 5. Then secant of theta, reciprocal of this one, that will be 13 over 12. And the last one, cotangent of theta, will be equal to 12 over 5, the reciprocal of tangent of theta. Number 3. Find other trigonometric ratios of the angle theta, given that cosine of theta equals 2 over 5. So in this figure here, we have here theta. Cosine of theta is adjacent over hypotenuse, meaning the adjacent side here is equivalent to 2. So this is 2 here. Then the hypotenuse is 5. This is 5 here. So what we're going to do next is we're going to find the value of the opposite side. So opposite side will be opposite side squared and plus adjacent side squared, 2 squared, equals the hypotenuse squared, 5 squared. So this is opposite side squared, and this is plus 4, equals 25. Then opposite side squared here equals 25 minus 4. So the opposite side here will be equal to 21. And extracting the square roots here, opposite side will be equal to square root of 21. So this is square root of 21. Then finding the 6 trigonometric ratios, sine of theta will be opposite over hypotenuse. So we're going to have here square root of 21, opposite side, over hypotenuse, which is 5. Then cosine of theta is adjacent side, so 2 over hypotenuse, which is 5. Then tangent will be equal to opposite square root of 21 over adjacent side, which is 2. Then if we're going to have the cosecant, this will be equal to 5 times square root of 21. Then this is denominator with radical sign, so we're going to rationalize the denominator. So we're going to multiply this one with square root of 21. So this will be 5 times square root of 21 over square root of 21 times square root of 21 is 21. Then secant of theta will be equal to, reciprocal of this one is 5 over 2. Then lastly, cotangent of theta will be the reciprocal of this one. It will be 2 over square root of 21. Then the same with cosecant. We're going to multiply this one with square root of 21. The answer here will be 2 times square root of 21 over 21. I hope this video helped you. If you have questions about the topic, please comment down below and see you next time.